Okay, think about what you're doing right now. You're watching this. You tapped a button, and it just appeared. Seamless, right? We think of this as totally weightless, almost like magic. We even call it the cloud, and it sounds like something that's everywhere and nowhere all at once.
But here's the reality check. The cloud is a place, a very, very real place, and it's a place that's heavily guarded, incredibly loud, and overwhelmingly physical.
You know, the gap between what we imagine and what's real is, well, it's huge. We picture something invisible, maybe a little magical, but the truth is intensely industrial. And out of all these physical realities, there's one that causes the single biggest problem. It is dangerously, incredibly hot.
And this is where it all happens, a data center. Now, when you cram tens of thousands of super powerful computers into one warehouse, you're not just crunching numbers. You are, for all practical purposes, building a massive, highly efficient space heater.
Just to give you a sense of scale, try to imagine 10,000 household ovens, all in one room, all cranked to the highest setting. That's the kind of thermal energy we're dealing with here. It's insane.
So what happens if you just let that heat build up? It's catastrophic. If left uncontrolled, those servers would literally melt themselves into a pile of slag, and we're not talking hours, we're talking minutes.
And that brings us to the real heart of the issue. The single greatest challenge of our digital world isn't really about storing your photos or processing your searches. Nope. It's a constant, high-stakes war against the fundamental laws of thermodynamics.
So the big question is, how on earth do you solve a problem that intense? A problem that can literally melt steel? Well, it turns out the solution is a masterpiece of engineering.
And the first line of defense isn't some giant air conditioner. It's actually the physical layout of the room itself. It's all about architecture.
See, you can't just pump a ton of cold air into the building and hope for the best. That's wildly inefficient. Plus, the cold air would never even make it to the servers stuck in the middle of all those rows.
So instead, engineers use this really clever design called hot aisle, cold aisle containment. Nothing is random. All the servers are lined up in these long rows, all facing the same way, creating these very distinct, isolated zones for cold air and for hot air.
And this is how it all works. Let's just follow the journey of the air for a second. Deep below the servers, there's this cavern where freezing cold air is pumped in, building up pressure. That pressure forces the air to shoot straight up through perforated floor tiles directly into the cold aisle. The servers then literally inhale that freezing air, pull it across their scorching hot components, and then blast the superheated exhaust out the back into the hot aisle. From there, that hot air is immediately vacuumed up into vents in the ceiling. It's this beautiful, precisely choreographed dance of air.
What you have is a perfect continuous loop that makes sure the hot and cold air never, ever mix. But here's the catch. This system is great for moving heat around the room, but it doesn't actually get the heat out of the building. And for that, you need something way more powerful than air.
So how do you get all that thermal energy out of the building for good? This is where the real heavy lifting starts.
To move this much heat, you need something that can absorb and carry a lot more energy than air can. You need something heavier. You need water. And that's why data centers rely on these colossal industrial-scale liquid cooling loops. You can think of it as the building's own circulatory system, and its only job is to absorb heat and get it outside. We can actually trace the heat's final escape route right here. So, that hot air from the ceiling vents, it passes over these big coils filled with chilled water. The heat jumps from the air into the water. That now hot water gets pumped all the way up to these gigantic cooling towers on the roof, and up there the heat finally escapes, evaporating into the atmosphere. And the newly chilled water, it's sent right back down into the building to start the whole cycle over again. Get this, the sheer scale of this system is just mind-boggling. The physical footprint of all this cooling infrastructure, we're talking the pipes, the pumps, the chillers, is often bigger than the space taken up by the actual computers storing all our data. So when you step back and look at the whole picture, you realize there is no magic to the cloud. Not at all. It's just a monumental, incredible feat of pure physical engineering.
The next time you stream a movie or, just pull up a photo and it feels instant and effortless, remember this whole hidden world. Our entire digital life is completely 100% dependent on this massive, roaring physical machine.
So, what's the big takeaway here? It's that there is no magic. There's just a massive, roaring physical machine engineered to the absolute limit, all working around the clock to keep our modern world from, quite literally, melting down.